Hi. Before we start our next lesson, I will be showing you a video. Okay, so looking at this video, what did you observe? What are your thoughts? What are your ideas about this video? So this will lead us to our new lesson, which is right triangles and Pythagorean theorem. The objective is how do we use properties of right triangles and the Pythagorean theorem to solve problems. So before we go even further, the video that you just saw was a demonstration of Pythagorean theorem. So basically that triangle that was in the middle was a right triangle, and the sides, basically the two legs and then the hypotenuse, if you square the value of those sides, you will get the Pythagorean theorem working for that triangle. So before we even go any further with triangles, we need to know what are the parts of a right triangle. So a right triangle is a triangle with one 90-degree angle, as you can see by the little marker. And you've came across this before with other triangles. The two sides of the triangle are called legs. They form the right angle. So we got the long leg and the short leg. When you put those two together, they intersect, they will create a 90-degree angle. And the hypotenuse is the side across or opposite of the right angle. So if the right angle is here, opposite, that side is the hypotenuse. So it says identify the parts of the triangle below. So as we can see, this slanted side, but the one that's sitting on its base, is the hypotenuse. And the reason why it's the hypotenuse, it's because it's across from the right angle, which is 90 degrees. Then we have the short side, and then the long side, which is, they're both legs. And then we have this line that is going from the right angle marker all the way down to the base. And notice that there's another little right angle marker. This is called the altitude. And the altitude in a triangle is also called the height, and is also perpendicular to the base of the triangle. So anytime you see a vertical line that creates a 90-degree angle and intersects or stops at the base, it is called the altitude. With the Pythagorean theorem, when you are given a triangle that has three unknown sides, or maybe two unknown sides, the theorem connected to that, is a squared plus b squared equals c squared. Most of you may have heard this before, so this is dealing with the right triangle. A squared and b squared represents the legs, and c squared, the slanted part of the triangle, represents the hypotenuse. That's the one that's also opposite of the 90-degree angle. Converse means the opposite. So for the theorem, it says given a right triangle, you will have a squared plus b squared equals c squared. The converse is, if you have a squared plus b squared equals c squared, then the triangle that we see here, KJL, is a right triangle. So basically, you're just saying the opposite of what was given in the theorem. So if you have a right triangle, then you can do a squared plus b squared equals c squared. If you can do a squared plus b squared equals c squared, that works out, then you'll have a right triangle. So we're going to do a few examples based on the right triangle and finding the missing side. For the first one, we need to find C. So C, this is the hypotenuse. The hypotenuse is always opposite the 90-degree angle. Then we have BC and AC, which are the legs, and their value is 20 and 30. So when it comes to trying to find the side of a right triangle, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. Plug in all the information that you need. Since we're looking for the hypotenuse that represents C, that's going to just stay empty until you solve for C. The legs BC and AC will take place of A and B. So if you use A, 20 for A, or you use 20 for B, it doesn't matter as long as that is designated for the legs. So you put your information in. C is going to still stay empty because you're solving for C. You simplify, you're basically squaring each of the legs. So you get 400 plus 900, which will give you 1300. And when it comes to dealing with squares, and in order to remove it, the opposite of squaring something is doing the square root, as you can see by this line. So that way C will remain by itself, and then what you do on one side, you do on the other side. So that means you're squaring the 1300. Now for this one, you could put in your calculator and get a decimal, but when it comes to problems like this, I don't want decimals. Unless I ask you for it, do not provide me decimals. Always put it in the simplest radical form. So you already learned this in 6.0 as a review for radical, properties of radical. So what you do is find, one of them is going to be a prime number, and the other number, the other factor, is going to be a number that will give you a perfect square. So as you can see, 13 times 100 will give you 1300. 100 will give you a perfect square of 10, and 13 is a prime, and it will stay underneath the radical because you can't break it down any further. And that is your answer for the hypotenuse C, 10 square root of 13. Same example with number 2, but the thing is they gave you the hypotenuse, which is 14, and one of the legs, which is 7. Again, you're still using a squared plus b squared equals c squared, and then you just plug in the information in the appropriate place. Since 7 is a leg, you can either put it for A or B, and since 14 is the hypotenuse, you have to put it in place of C. So once you do that, then you're solving for one of the legs. In this case, it's B. You continue, you simplify, and then since you need to have x by itself, you subtract 49 on both sides, and you get x squared equals 147. And since you still have to isolate the x, the variable, you're going to do the square root on both sides, because we're trying to get rid of the square. Once you do that, 147 can be broken down into two factors, which is 49, which will give you a perfect square of 7, and 3, which is a prime number and will stay underneath the radical. So then your answer for yz, which will be b, is equal to 7 square root of 3. So that's using the Pythagorean theorem to look for either the hypotenuse or one of the legs. So when do we use the Pythagorean theorem? What is given? Two sides of a right triangle. So if you have two sides of the right triangle, you can look for the third side. So that's when you use the Pythagorean theorem. It deals with sides, not angles, sides. And when do we use the converse? When you want to know if the three side lengths will form a right triangle. So basically you're verifying, you're checking to see if the three sides that they gave you will give you a right triangle. And in order to do that, let's say that they gave you the three sides, 3, 4, 5. You would use the Pythagorean theorem. You ask yourself, is it a right triangle? You would use the Pythagorean theorem, a squared plus b squared equals c squared. You plug in your numbers, and remember, the hypotenuse is always opposite the right angle. So basically, you're trying to verify that these three numbers will give you a right triangle. And when you plug in the numbers in its appropriate place, you can see that 25 equals 25. So this is definitely a right triangle. So yes. And do not confuse this with the triangle inequality theorem. You learned this last year. Basically, it's when they give you three sides, and you have to figure out if you can use those three sides to make a triangle. And remember when we had to take two sides and made it greater than the third side, and then we do two other combination and test it out. And in this case, since all of the two sides added up is greater than the third side, you can create a triangle using those sides. But these two are different. When you try to find out if a triangle is a right triangle, you use the Pythagorean theorem. When you want to know if you can use three sides to make any triangle, then you do the triangle inequality theorem. Two different things. With Pythagorean theorem, you have three sides. We usually call them triple. So Pythagorean triple consists of three positive integers, which is a, b, and c, such that a squared plus b squared equals c squared. That's all it's trying to say, that if you have three numbers and you plug it into the Pythagorean theorem formula, and if it works out, then those three numbers are triples. So we're going to do the example. So I'm going to put it into the Pythagorean theorem. Just let me change that. So we got a squared plus b squared equals c squared. I'm going to make 8 as a and 15 as b, and then 16 squared. So now I have 64 plus 225 equals, make sure that one comes out to 256. When you add up the 255 and the 64, you'll get 289, but that is not equal to 256. So no, not a triple. Let's try number 2 and see if that works. Again, we're using a squared plus b squared equals c squared. We're plugging in our numbers. 48 and 20 will be our legs. That's a and b. And then our hypotenuse is going to be c. So then this will become 400, and 48 squared gives us 2304, and then 52 squared will give us 2704. When you add up those two, that's going to give you 2704, which also equals to 2704. So yes, 20, 48, and 52 are triples. So going back to that video that I showed you, where the girl was using a right triangle and have the sides that are squared and filling up one side with water and then the two other squares with water. So if you were to use these numbers 20, 48, 52 and create that right triangle and then square the sides, so that means 20, you would have a 20 by 20 on one side and a 48 by 48 on the other side, and then the hypotenuse would be 52 by 52. If you were to fill up that water in a 52 by 52, turn it so that way it fills up the two other squares, it would fill it up completely. So then that would prove that the triangle, that three sides will form a right triangle. So that it's all connected. Okay, we talked about Pythagorean triples. The next one is Pythagorean families. So basically it's just when multiplying each number by the same number, so you got a factor, another Pythagorean triple is formed. So basically, by showing you the example for the first one, we got 3, 4, 5. And get used to that 3, 4, 5 because that is like the common right triangle that you always hear, that they always use, 3, 4, 5. So if I took the 3, 4, 5 and I multiplied each of them by 2, I would get 6, 8, and 10. So 6, 8, 10 is a triple, and it's part of the 3, 4, 5 family. If I multiplied it by 4, 3, 4, 5 by 4, I would get 12, 16, and 20. 12, 16, 20 is a triple, and it's part of the 3, 4, 5 family. Let's do the other example. 8, 15, 17. If I were to multiply it by 2, I would have 16, 30, and 34. So that means that 16, 30, and 34 are triples, and they're part of the 18, 15, 17 family. And let's just do one more. If I multiply this by, say, 10, this would be 80, 150, 170. 80, 100, 150, 170 are triples, and they're part of the 18, 15, 17 family. So that's all that they're talking about with the Pythagorean families. You're just taking a number, multiplying it to the three numbers, and you're going to form triples, and it's part of that family. Okay, we're going to use the Pythagorean theorem and apply it to a real-life problem. So it says, NASA's Dryden is located about 117 degrees longitude and 34 degrees latitude. NASA Ames is located about 122 degrees longitude and 37 degrees latitude. Use the lines of longitude and latitude to find the degree distance to the nearest 10th between NASA Dryden and NASA Ames. So here we have a diagram. We need to know what longitude and latitude means. So most of you may know what that is, others no. So longitude is the horizontal line. So think of the word, it has the word long. So long, how long will it take you? How long is this line? So sometimes you think of it in terms of width. So long is horizontal. So then that means latitude is the vertical line. And now the red part is the distance from NASA Ames to NASA Dryden. So that's what we're looking for. And notice that it creates a right triangle. So we need to use the Pythagorean theorem to find the longitude distance, the distance from NASA Ames to NASA Dryden. So we need to know what the distance is of the longitude. So we're counting based on the degrees that are on this map. So from 122 to 117, that would be 5. And then the latitude from 34 to 37 will give us 3. So we have the two legs. Since we have the two legs, we can find the hypotenuse, the degree distance from NASA Ames to NASA Dryden. So we use our Pythagorean theorem. We plug in our 5 and our 3. So it doesn't matter. In this case, I use the latitude as A and the longitude as B. You could switch that, but as long as it's for the legs, you're good. You simplify, and then you get 9 plus 25 gives you 34. And since you need to get C by itself, you have to do the opposite of squaring, which is square root. You do it on one side, you do it on the other side. And then since they're looking for a degree distance, so you need an actual value, you're not going to say, oh, the distance is square root of 34. So in this case, then you give me the decimal. So for this one, since it says to the nearest tenth, it will be 5.8 as the distance, the degree distance from NASA Aim to NASA Dryden. And using the Pythagorean theorem, you could use it anywhere, especially if you're like trying to find the shortest distance from 2 points rather than taking 2 streets. You could cut across, so that way you can measure, okay, how far would it take me from one point to another rather than taking two turns to get to that point. All right, so we've reached the end. Just going to do a recap. So we learned about the Pythagorean theorem. Well, we learned about that, and we learned about the right triangle. We learned about the parts. There are 2 legs, the long and the short, and the hypotenuse, which is opposite the 90-degree angle. We also learned that in a triangle, a right triangle, if it's laying on its hypotenuse, then the altitude would be the line that starts from the base and goes straight up vertically, and that will create a 90-degree angle, and it will be perpendicular to the base. We also learned that the converse and the theorem, so the Pythagorean theorem is a squared plus b squared equals c squared. That's if you have a right triangle, and if you can do a squared plus b squared equals c squared, then your triangle is a right triangle. You need to remember that the converse for a right triangle is different from the triangle inequality theorem. You use the converse in order to find out if the triangle, the numbers that they gave you, form a right triangle. But if you want to know if 3 sides can create a triangle, then you use the triangle inequality theorem. And triples basically are 3 numbers that you put into the Pythagorean theorem and see if it works out well. If it does, then the triples can create a right triangle. If not, then you just have a regular triangle. And the Pythagorean families, is basically taking a factor and multiplying that same factor to the 3 numbers to create families that will form triples. Okay, so this ends our lesson. See you around.